Okay. Happy Wednesday, everyone. Not sure if people say happy Wednesday, but I'm saying it, so, okay? So again, there will be homework available today at 2 o'clock on Lumen, okay? It will be due Tuesday of next week by 11:55 p.m. Excuse me. It's also in the calendar on Blackboard. I'm trying to use the calendar feature as well that comes with Blackboard. Okay, so the homework will be up there today at 2 o'clock. And I do expect to put a quiz this weekend sometime up there, but again, I will let everyone know and I'll give you time to do it, okay? You know, they're not gonna be time where you have to complete the quiz in one sitting, so, okay? You know, everything is essentially take home. I think that's all I needed to say. Are there any questions at all? Yeah?
I joined a little bit late. Can you say what you said about the homework again?
It's going to be available today at 2 o'clock on Lumen.
Okay.
Okay. Okay. Okay, good. I think that's all I have to say. Yeah, okay. So let me stop the camera and let me now start lecturing. Is anyone else's audio weird? Does anyone have trouble connecting? Because I know that happened in the other class. I think they logged out and logged back in. So, whoa, hello. Oh, boy. All right, let me get my notes. If I can, where are they? Oh, this is it. Okay, let me, well, they can't see that yet, so I want to share my screen with, there they are. Boom. I don't think I'll get to that worksheet that I emailed everyone. I did email everyone the notes, but the worst case is I can always post solutions to the worksheet. So, you know, you have more examples to work from, okay? All right, cool, cool. All right, so I think everyone can see it. Okay, let me start lecturing now. Okay, so last time I did mention this, that we are going to begin looking at multiplication. So basically, just like with addition and subtraction, remember how we started with monomials and then we went to, what do you call, polynomials? We're going to do the same with multiplication, okay? And now first we want to know, so in other words, we want to know first, how do you multiply two monomials together? Well, that's what this equation is telling us. And what is this saying to do? You multiply the coefficients together like so. You do A times B. And then, okay, for the variables, we do x raised to the m plus n. Okay, we're using our exponent rules here, notice, okay? We're doing x to the m plus n. We're adding those exponents. And so this is just how you multiply monomials together, okay? Now, and I just did some examples here. We have 4x times 7x cubed, okay? So how do you multiply these? We have 4 times 7, right? And then we have x times x cubed. Excuse me, then we have x raised to the 1 plus 3. Remember, the exponent is not written here, right? So it's understood to be 1. So we get 4 times 7, which is 28, times x to the 4th. So that's really what we're doing. And over here, same idea. Minus 5 times 20. And then we do times x raised to the 7 plus 6. Minus 100, x to the 13. Okay? Like so. So really, that's just how you multiply monomials together. And now we can move on to polynomials. So basically from here we have distribution. That's one method of multiplying. There is another method that I'm going to show you as well, called the box method, or the grid method it's also known as. I will show you that as well, But let me just do a little distribution first. So basically with distribution, you're multiplying, again, two polynomials together, right? You're going to take each term from the first polynomial, and you're going to multiply it with each term from the second polynomial, and then you get to add. So let me say that again, even though it's written there. You're multiplying each term from the first polynomial with each term from the second polynomial. And then what you do is you add the results together. And it's good to write your answer in standard form. So here's an example. So we have 4x times 7x cubed plus 1, right? So that's going to be 4x times 7x cubed plus 4x times 1, right? And notice how we're going back to the monomial case, so to say. We have 4x times 7x cubed. That's 28x to the fourth. Anything times 1 is itself, so we just get 4x here, and we're adding the results. Okay, that was fun. That was awesome. Let's try another one. Okay, again, if I go too fast, just say something. I can't see the chat, though, so just letting you know. So for this one, again, we're going to multiply each term from the first polynomial times each term in the second. So we have x to the 4 times 2x squared, as you can see. X to the 4 times x to the 5th, like so. 3 times 2x squared. And then we have the 3 times x to the 5th, like so. And so from there, we carry out these products, right? Using, multiplication of monomials. For this product, we get 2 times x to the 6th. Here, we get x to the 4 times x to the 5th. That's x to the 9th. Here we get 3 times 2x squared, 6x squared. Here, we get 3x to the 5th. And so from here, then, what do we get? We get x to the 9, right? Plus 2x to the 6. So I'm writing it now in standard form. Remember, you want the exponents of x decreasing as you go from left to right. So we have x to the 9 plus 2x to the 6 plus 3x to the 5th plus 6x squared. That's what we get. And now it's in standard form, as you can see. Right? The exponents of x, the variable, they're decreasing from left to right. Are there any questions on this one? All right. And really what I just did, you might have seen before. It's called FOIL. FOIL stands for first, outer, inner, and then last. Because that's really the terms you're combining. First, F, the first terms. Outer, the outer terms, A and D. Inner, the inner terms. Last, the last terms. That's what we get here. And that's what FOIL is. I mean, my experience teaching this course is that most students know that already. If you don't, that's okay. I mean, it's just distribution is what FOIL is. But it is also a shortcut for remembering how you can multiply two binomials together. A binomial is a polynomial with only two terms. The prefix bi, like in bicycle. So, all right. For this example, we can use FOIL. First, 3x times 2. Outer, 3x times minus x. We don't forget the minus sign. Inner, 4 times 2. last 4 times minus x, or minus 4 times x. But let me say it again. 4 times x, but we have the minus we put in front. Okay. So this is actually an example of FOIL. Let's carry out these products. The first one is 6x. This one here, minus 3x squared. This one here, 4 times 2 is 8. This one here, minus 4 times x. So what do we get here? We have minus 3x squared. Again, we want this in standard form. This is the highest exponent of x in this problem, minus 3x squared. Then we have 6x minus 4x plus 8. And of course, these are like terms, so we should combine them, and we get this. We get that. Okay, that's FOIL. You know, if you know that already, great. If you don't, that's okay. All right, that's fun. Let's do some more examples of FOIL. Again, if I'm going too fast, just say something. I won't get upset. So for the first one here, right, 2x to the 5th times 3x squared, that's the first term. Actually, you know what? Let me draw it in. I did that for the other class. That might help. So we have the first terms we have, as you can see. Then we have the last terms. Excuse me, not the last, the outer terms, the ones on the outer edge. So you can see that's where the next one comes in. Here we had the first terms. Here we had the outer terms. Okay. For the inner terms, that's the minus 5x and 3x squared. So over here. Then we have the last terms, which are minus 5x and just x over here, as you can see. That's what we get here. Okay, so if we carry out those wonderful products, the first product, what is that? That's 6, x to the 7th. Here we have 2 times x to the 6th. Here we have minus 15x cubed. Here we have minus 5x squared. Okay, that's a fun example. This one and this one's going to be a little bit different. Here we have x minus 3 times x plus 3. So if you FOIL those, that is if you use distribution, and I'll get to that in a second. I got to change the recording. Oh, someone have a... Oh, okay.